Okay, ready to go. So first of all, welcome to this talk about technical debt. Just a quick introduction. My name is Fernando Cejas. I think I'm kind of became part of the family here because it's my fifth version. I've been in since the beginning here in Krakow. Always very happy to come over. Thanks to the organization for the invitation one more time. Yeah, as I said, a quick introduction. Yeah, my name is Fernando Cejas. This is my contact information in case there's something after the talk you want to talk about, or just if you want to ping me or whatever. I'm just here, as I'm pointing out on the presentation, to just share all the disasters I made as a professional in the last few years. I mean, there's way more, but like the last one were the most chaotic, I guess, because of the complexity of different projects. So we are here to talk about technical debt. I know that that's a topic that we are all familiar with, especially since we're all dealing with it. I mean, I have never seen a code base without technical debt or legacy code. But there's something that I don't have a pointer, by the way, so I'll be going back and forth a little bit. I like to move. Just feel free to stop me whenever you feel like asking anything. I like to interact with more than following up as an agenda or so forth. So feel free. Otherwise, we just continue and then we talk afterwards. So my starting point would be this statement here. But code is always imprudent. That means no matter what I'm telling you here, there is never a good reason to write shitty code. We have all done it. Sometimes we do it, and we're going to see there's specific points in time where we can decide about it. But anyway, there's never a good reason to do that. So in order to get started, we're going to define a couple of concepts here, especially since probably you're familiar with the concept of technical debt and legacy code and all that. But you know that between developers we have, or engineers or managers, whoever is into IT, we have this common language, right? And we need to agree on specific things, what they mean and so forth. So just to get started and to go little by little, we know that in an ideal world, our projects most of the time are finished on time. They're, they have a huge, super high code quality. They're on budget. What else? You can even add additional features, and you're able to test it twice. I guess that's never happens, or at least that never happened to me, right? If you're in this level, you unlock the superhero level here of technical debt and so forth. So you can leave the room, you're happy. Otherwise, welcome to my world. So the one that I live in, and probably most of you. It was obvious that I was going to use this meme here. First, why? Because our software is terrible. We know that. By the way, I'm going to be using some GIFs here related to Batman, my favorite version of Batman from Madame West in 1966. So hopefully you're familiar with that. So we know that our software is terrible, that we create huge monsters, huge monsters, these big beasts full of legacy code, issues, bugs, and so forth. And we know that that's true. I mean, I've never seen any code base without any issues or any legacy code, right? By the way, I don't know what happened with the font over there. Anyway, so let's go and quickly define what is legacy code. There's tons of definitions out there. And I would say these are the most popular when you read about legacy code. you read books, blog posts, or you talk to people, most of the time people say, okay, it's code without tests, code difficult to change, anti-patterns, things that you see over there. There's no separation of concerns and so forth. I would add, it's a mix of all this, and every single definition adds up. But for me, it's like code without tests is the most accurate for me. We are going to be inspecting some code bases, and we will see, what legacy code is. So there's another concept. Are you familiar with the concept of reckless debt? So if you're not, let me quickly define it. I bumped into this concept after working with a bunch of people, and they were talking about reckless debt. And I just said, what is reckless debt? I mean, it looks like we're all familiar with technical debt, but what is exactly reckless debt? So, well, it turns out that reckless debt is code that violates design principles. I think, in most of the time when you read about it, you can exchange it with technical debt. They're both synonyms. So if you see it that way, it's totally fine as well. But in reality, that means this code that is violating design principles, but without being written on purpose. So when you have reckless dev, it's actually like whatever line of code that you're writing, it's junk, basically. But it's not because you're writing it on purpose. And sometimes you have to decide whether you add some technical debt because of other factors or whatever. But in this case, maybe the fact that you have reckless dev is telling you that your team is not well trained, for example, because everything, and there is a lack of knowledge, and every single thing that they're writing is not, well designed, or is not pretty clean. It could also tell you that your team needs training, again, because of the lack of knowledge, or you have a lot of juniors developers. So this is how people in this area are using this concept of reckless debt. So in the end, what is technical debt? As we know, that comes from financial debt, and that's something that incurs with an interest, something that we need to pay afterwards, in the future. And translated to IT, it's some effort that we will have to pay in the future, right, for some dirty design choice that we have made. So that's pretty much the basic definition. I would say, in essence, technical dev is the additional effort and work required to develop a functionality, for example. Because you estimate something and then it turns out it takes longer. So that additional effort that you're putting into it could come from technical debt, some dirty design or legacy code or code that you don't understand, and so forth. Here's the thing. Most of the time, we just say there's a one-on-one relationship between technical debt and legacy code. We will see that that's true, but let's keep it this way for now. So I'm going to go pretty quickly through this. Let's say we need to add a new feature. We can go for the easy way, where we're saying, okay, I'm going to just write messy code. We need to do some prototyping and so forth, and I'm going to be faster. So I decide to incur on some interest in the future by just writing this shitty code. Or the hard way, where we go for a more cleaner design, and that's going to be more effective in terms of technical debt in the future, but it's going to take more time to develop that. So here's the first tip when it comes to technical debt. And now I'm going to give you an example here and something that I experienced. So sometimes you have to accept some technical debt for tactical reasons. Maybe you're running a market experiment, for example. How many of us have been developing a functionality and we need to do a market experiment, and we just say, okay, let's do it like the dirty way, and then we see what happens. Another tactical reason, and this is something that happened to me last year actually, we were working in a code base, and we needed to provide some kind of framework to the rest of we were working in core team, right? And we needed to provide a framework to develop functionalities of the app a little bit faster. So we came up with this framework, and this framework, the development of this framework was a combined effort from several teams. And we had a deadline, and we said, okay, we were not meeting that deadline. You know, our small team, our tiny contribution would not make it within the deadline. So we decided to get some technical debt. So we decided, okay, let's do it faster. We're gonna write this code not in a very good way. And in the meantime, we documented that, of course, and we will see that, you know, some practices in order to address these kind of issues. And then we decided to pay the interest later. So we would effort and we would make an extra effort afterwards in order to refactor that piece of code. So you had to accept some technical debt. When to make that decision, we will see after analyzing a couple of code bases. So the first thing, and here's the interesting part, I would say. Now we agree on specific definitions, on specific practice things. I think we're all familiar with this concept and so forth. And this is the core of the talk, detecting technical debt. And some practices, these are based on in experiences with big code bases and how we address that. There are specific levels. So the first one is the rookie level. And I think we're all familiar with static code analysis. The first thing you might do, if you're doing Android, you might have a lint, you know, checking your code statically, doing some analysis and so forth. There's other tools, open source tools that you can use in order to do static code analysis. But what is static code analysis? It's just grabbing, in a few words, in a nutshell, it's just grabbing your code base and analyzing it and measuring some stuff. Which stuff? Most of the time, these metrics that you need to understand. Then you have cyclomatic complexity, which is the number of functional paths in your code. So the more paths you have, the more if clauses, the more switch cases you have, increase the cyclomatic complexity. That might tell you something. We will see then what. Code coverage, we know that, you know, code covered by tests. I think you have to be responsible here a little bit, because code coverage, for me, it's a measurement, it's a metric that could lie a little bit. Because I remember, like, back in the days, we were actually doing an experiment, and it was, okay, let's increase code coverage. And we started testing getters and setters. And that's that, okay, yeah, look, we are 90% covered. But that 10% was, you know, over the domain layer, which was now covered by tests. So be responsible by using this metric. SQL rating, this is a metric that goes from A to E, being A the highest quality. So I don't know how that works under the hood. There's some analysis, you know, between functional path and coupling and so forth, but it's a very well-known metric. The rule violations based on some code, some conventions. I think that's what lint is doing basically too. And bug count. Bug count, I mean, how many of us are piling up bugs and we never know when to fix it or how to fix it and so forth. We just ship the next version of our app, and our, you know, number of bugs is increasing. So that means, you know, a degradation in the quality for our code base. So so here's the thing. The problem with code analysis, static code analysis, is that all these metrics must be developed for every specific language. So every specific language, let's say Java, Kotlin, must have this complexity, this kind of things particularly for that specific language. Just like I'm going to show you a bit here. And there is like this, so you can see that, right? Yeah, cool. So there is, for example, one of the most popular open source static analysis tools is Sonar Cloud. It used to be Sonar, and then they renamed it to Sonar Cloud. So I just grabbed an open source project, which is called Monica. Monica is kind of a personal relationship manager. So if you're interested in that, yeah, I was just like playing around that and wanting to see, you know, did some analysis here, check the number of bugs and how they have been, yeah, covering specific things. I think you can go in deep and see there's no coverage here, 0%. So as you can see, technical dev is kind of yeah, normal, I would say. Yeah, so just you know that there's tools like these ones that can help you out a little bit with static analysis. That, I would say that's a rookie level. Then, yeah, let's go with the next one. The experience level, unlocked. We're to this point, and I want to introduce the tech dev radar. If you're familiar with the radar concept or the technology radar from ThoughtWorks, it's kind of, we got, while I was working at SoundCloud, we got the idea from there. And it's a practice that they are still doing it, and I, you know, brought it to other companies, to other people that I work with, and I think it's very useful. And I'm telling you, it's a process. And what is a tech dev radar? So when you're working with a technical dev, I like to call this like a technical dev detector by experience. So as you can see, this is a board. So here's the thing. You might grab your entire team when you want to analyze your code base. People who are working with this code base. You might just catch up in a room, draw these two axes, X and Y, and then everyone would post or would write down some post-its with the part of the code base they're working with. So if there's someone working with dependency injection, some other people from the feature teams or whatever team structure you're using, just would write functionalities of part of the code that they have been working with. What happens? As you can see here, these two axes, one represents the development time, which could be high amount of time or very little time. And then you have here the y-axis, which represents how much pain that functionality is causing within the code base. For example, how many of us, you know, sometimes or yeah, anytime had to dive into a specific part of the code, oh God, I don't want to touch this because no one knows how that works. So you would just gather all this information and would put it, you know, depending, everyone, it's very subjective, I would say. Like it has to do, you know, how you feel about that. For example, let's say DI, dependency injection. I remember this is a kind of, yeah, real use case. So back in the days, we had a very messy dependency graph, and no one wanted to touch it, no one wanted to refactor it, and it was causing a lot of problems. So what does that mean, that dependency injection is over there? As you can see, it's telling us that it's causing a lot of pain because it's making our app to run pretty slow. Startup time would take more seconds and so forth. But it will also take a lot of time to refactor that. So whereas if we take logging, for example, on the other side, logging is something that it's causing relatively a lot of pain, but development time in order to fix it would take not very long. So what is this here telling us? That maybe it might help us to prioritize, to restructure, to plan our technical dev approach in order to kill it. So maybe logging is, okay, let's add a lot of value in no time. Let's go first for logging, because it's causing a lot of pain. And then, of course, like with the rest of the other features, you had to reevaluate. But here we are analyzing. And trust me, I mean, you need to keep track of this. I mean, if you're gonna try it out, I would say just do it every 3 weeks, 2 or 3 weeks. Keep track of that, how everything has been moving around, if you had time to replan it or not, if it got better or not. I think within the experience, it's one more tool to your toolbox. So that's the thing, DevRadar. And then we have our guru level. This is something new. I've been playing around for a year more or less with this. And this is behavioral code analysis. What does that mean? I mean, if we go back to the static analysis, we just said that technical debt is reflected on legacy code. We agree on that at that point. But it's not the only factor then. I mean, we got to the conclusion that nowadays all the tooling has been changing. Everything is more social. Let's grab GitHub. I mean, all this interaction between developers. You can see a lot of curious things over there. Bottlenecks, who is communicating with, and so forth. So it's not only about the legacy code. It's about the organization itself. The structure, how many developers are working in a specific part of the code base, remote workers touching, I don't know, many files and so forth, without us being aware of that, for example. So what is behavioral code analysis? It's an analysis of your code that takes into account the organization and the people. And it adds a new dimension. As we said, a static analysis, it will grab a snapshot of your code base, it will analyze it with all these metrics and so forth, and that's it. It's lost in time. But how can we make sure that things have been evolving? How can we make sure that the changes that we did in the past are reflected right now, and we are moving towards the right direction? We need to add a new dimension, and that's time. And it's, again, it has to do where can we get all this information? It's pretty simple if you think about it. We have it in our version control system. It's a gold mine. All the stuff you can see from your Git, for example, who interacted with, how many people touched this specific file, everything with its own date, and so forth. And there's tools that can show us that and makes our lives easier. There's specific metrics, and we're going to see a tool that I really like. I'm going to show you some stuff. But like, just keep this in mind. The same way we have metrics for static analysis, we have metrics for behavioral code analysis. And that's hotspots. We're going to get back to that by showing you an example. But just keep in mind, hotspots identify wherever in the code there is more development activity. So it's a mix of complexity. And complexity here, when you would ask me, oh, how you measure complexity? This tool, what it's doing basically under the hood, we will see, complexity is measured by the number of lines of code. Plus, developer activity. That means the files, the classes, or that are being more more frequently changed. Plus, they're the most complex ones. That's a hotspot, and we will see that in action. Change coupling. Keep this in mind. What I was mentioning before about the snapshot and the part of time by just seeing how much progress. What is change coupling? Sometimes we don't realize that every time we touch a file, there's 2 or 3 files that are being modified or have to be modified as well. That's telling us something else as well, right? It's telling us, oh, maybe there's some design issues here. Why every time that I touch this file, these 3 ones must be touched? Maybe there's some architectural issue here. It could be telling me something. I mean, there's false positive with all this, of course. And all this analysis that we're going to see right now, it takes time and effort in order to do it, in order to understand what's going on. But for example, within the change coupling, I mean, if I'm changing a class, I might expect that if I'm changing kind of the behavior or something, I'm expecting to change also the test class for that. So that could be a false positive as well. Code biomarkers. Biomarkers this comes from medicine. Biomarkers like kind of a metric that stands for how ill an organism is. And we will see that as well. So for doing all this, I've been using a tool called CodeSyn. This tool, I don't know if you're familiar with. It's an open source tool. It's not open source. Part of it is open source. You can use it for open source projects for free. I mean, I'm not advertising this tool at all, but just like found it very, very interesting. And there's a bunch of examples that you can see here. We're going to go and analyze something. We're going to check it out. So for example, in this case, I was curious about the MVC from Microsoft, because I found that for some reason, there were a lot of issues within this code. MVC is a .NET framework used for MVC, of course, with ASP too. So I got into the code. Here, you can do the same with your open source projects, by the way. And I was actually checking a little bit, some information here. I went to here you can see a technical debt menu, and I went to the hotspots. Hopefully there's a demo effect and internet connection works. Yeah, as usual. Let's see if I can go somewhere here as well. Let's open the other one as well. Okay, wanted to show you some stuff here. It was very, very interesting. Okay, cool. Nope. This is working. Yeah. Okay, cool. So here's our hotspots. Remember what were they? Like complex part of our code that were touched by many developers, or the frequency of change was pretty big. So I mean, this is organized by structure. I mean, every bubble represents a folder, and you can go deeper in the hierarchy. Like for example, I was checking all this dependency injection, this folder, and then I was here, and then I wanted to see this hotspot, which is pretty red. So that means a lot of complexity there. So I just got into this, and then you have here more information about this, which is pretty interesting. you can see here the change frequency it's pretty high. This class actually had like 1,300 lines of code, which is pretty bad, I would say. And then you have a complexity trend, how things have been going, over the time. As I said, adding this time dimension here. There's very interesting stuff that you can see here. That again, like this is about like analyzing your code and then, making decisions about all this. You can do something here. I mean, you can either view the code, because I was interested. I want to see the code here. Well, it went to GitHub, but there's this thing that you can do, which is called X-ray. And then these are all the methods contained in that class. And I was checking out and say, okay, as I can see, I can go more granular here and say, okay, this create invoker method, it's being changed so frequently. And what is this? It has a very high complexity, and it's here, and cyclomatic complexity of 11, which is pretty bad. Then I checked the code actually, and I saw that, okay, check all these ifs, else clauses here. If exception is null, if this exception is equal to exception, and this is overloaded, I don't know how many times, as you can see, it's 3 times at least, and there is a lot of complexity, but it was pretty hard to understand why. And this is one method. I know that, and we can go like very granular here. This is telling us, again, something. It's a very deep analysis, but I found it like very, very interesting. If you can do something like this within one of your open source projects, just go for it. You will see like really interesting stuff. Something very interesting, as I said, then you can go to the code health. So this tool is also using machine learning in order to detect patterns, changing patterns and so forth. And as you can see, the same class here, when I'm going to this code health hotspot, it's telling me how it was over the time, and it's giving more information about what's going on. It's not that I have to analyze the code myself, because sometimes I don't understand it, or it might take way more time. But this controller action invoker, it says that here what the tool is doing is analyzing the code and putting some characteristics of the analyzed code. Like, for example, it's telling me that this is a brain class, and this means that a brain class is a class with a lot of responsibility. It's not respecting, a single responsibility principle. There's low cohesion. There's duplicated code, as we could see with all this overloading, and so forth. Again, from here we can do the same X-ray analysis and so forth. Then we have, by using machine learning as well, we can do a refactoring targets. You have to keep in mind as a tech lead, or if you're a tech lead, or if you're a manager, or even developer, you can make decisions based on this. And it's a very nice way to communicate technical debt. Because sometimes it's like, oh, yeah, we cannot work with that part of the code. Why? Because it's too crappy, and that's it. But we need to demonstrate that most of the time, because mostly the upper we go into the layers, the less technical dev is understood. And let me show you another interesting thing. Here, the temporal coupling, which is, I think they renamed it, but it was a change couple. So as you can see here, these are files that are changing constantly. Every time that I change one, it changes a bunch of them. And I can see it here in a very graphical way. You see, like, for example, if I see every time I touch this, that carries also changes to these other 3 files, for example. And then you can put all this information together and have a better understanding of what you're doing as an engineer, really. And detect bottlenecks. For example, Because one of the things is a piece of code that it's complex, but it's never changed. Is that technical debt? That's very opinionated, right? I would say no. I mean, if we barely touch that piece of code, it could be legacy, or maybe not very well designed, but maybe I need to address other part of the code, right? Which are being changed more frequently. Something else very interesting, you can see all this from your code base. The social analysis, I've been checking this out. Yeah. So this is basically how, for example, you can add your teams based on your GitHub, on your version control, and you can add your team members here, and then there's going to be a relationship map, who interacts with who. So like here, so I think I was checking. This is React. This is the React library. It was an example here as well, and I was checking social networks here, and it was quite surprising because it looks like, for example, when with this person here, it looks like this person interacts with pretty much everyone here. And this one, for example, interacts only with one, and so forth. Maybe it's telling us that there is some bottleneck here, and some people are being overloaded, or doing so many things, or touching many parts of the code, or interacting with some other part of the organization, and so forth. And you can go further and do like some cross projects, social networks, and see that. So you might be burning out people, for example, as well. And there is way more to, I think, yeah, we're running out of time, but definitely would love to show you way more about it. If you're up for that, I'm going to be today and tomorrow here, and we can talk about that. So with that being said, this tool has been very interesting to me in the last year, because of that, because of the organizational part. You know, we are no longer being only individual contributors, just writing the code and just, you know, let it go and all that. There is a lot of connection points, especially everything is going social nowadays. So in the end, all these kind of approaches here is helping us to ask the right questions, right? It's not about like, oh, that's the real truth, what we need to care about false positives. We need to really, it takes a lot of time as well, but you really learn a lot from how your organization works, how your team works, and how you're connecting with the rest of the people, organization, and whoever. And again, you need to ask yourself the right questions. Where we should focus improvements? Where are the risk areas in the code? Here. Or maybe there is some bottleneck somewhere because so many conflicts. I was checking a Codebase, and yeah, that was a few months ago, yeah. So I think like 80% of the code was, sorry. 80% of the development activity was in 10% of the code. So there were a lot of conflicts there, and then there were a lot of productivity issues there, because a lot of conflicts and people not being able to communicate with each other, someone having a separated branch, and then 2, 3, 4 branches, people working on the same part of the code, and then how you would put all together. It was chaotic, really. With this, at least you can have a clue where is that coming from and how to address these kind of problems. So again, I would like to almost finish with this quote, which is again about the social part. Some of your people can tell you about your code. That's true. Some people know a lot about the code bases, but your code history can tell you about the people and how they interact with each other, and why some issues are happening that cannot be detected with a normal static analysis. I have an extra vault, and this is more like a visual tool I wanted to show. This is very curious as well, because it shows developer activity. It's called GURS. I don't know if you're familiar with that. And I just check out the React project. I wanted to see how developers were interacting, how they were moving. It's pretty interesting. You just download, install the tool. You just run GURS on any Git project, for example, and this is what you get. And I was checking here. Here's like the React repo, and every lift here, and it's represent the file and how developers are moving around that. I mean, sometimes it looks good, right? I mean, probably it's not that useful, but one of the things that we used to do, at a couple of companies I work with, is to plot this into a screen and just see the sprint activity. I was pretty curious to see who was working on what kind of things. I think this is 2000. You can go through the entire timeline. I was checking here at some point. It got crazy when React became popular. I think. And for your project managers, this is super cool. It's like, okay, here's how we are working, and and it's a very interesting tool if you want to go deeper. I think there's a bunch of options. You can also put your emoticons, your images that represents you in the code base and so forth. There's a bunch of options. You can go to documentation. I'm going to share all this after the presentation. I think we're reaching to an end. I have, just in case that would not work, and just paying technical dev, I'm going to go quickly about this. So you analyze that. You have your information about your code, your analysis, and so forth. So how you pay technical debt. So I would say at team level, always make it visible. There's a bunch of techniques that you can use. Always allocate some time to kill technical debt. Don't let technical debt just increase. That's snowball effect. At some point, the bomb is going to blow up, right? And always be transparent. You have all the tools to make it transparent, to educate people to understand what we are talking about. And just use, for example, there's management debt as well, and business debt as well. So you can use all these concepts, and they pretty much doing the same thing. It's based on decisions that you're making that would incur into an interest. So use that as well, plus all this information and documentation. At a company level, I don't know, it sucks. Make it transparent and communicate it properly at both levels, especially to people who are not familiar with technology or with the concept of technical debt and what it represents for us as engineers and so forth. Something that could also help you out to measure it or to make easier the communication is to track the cost of delay. When you're estimating something and it took longer because of technical debt, just document that time, that extra time that you spent developing this functionality. And that is how, that is ralentizing you. And this is another measurement, okay, to say, okay, we need to address this, because this is the cost of delay, it's increasing over the time. And it's not easy to get rid of a bomb. Batman says that, especially since we all live with this. But sometimes you can make it. There was a video, but I will send it via. It's a Batman thing. It's a nerdy stuff. A 2 minutes video, but in the end, it's not easy to get rid of technical debt. But just make sure that you're addressing it. It's very, very important. I mean, at least in my experience, it's something that always cause problems. At some point, yeah, you're gonna get really fucked up. I think that's everything I have to offer right now for this talk. I'll be around. I'm very interested in getting feedback, getting experiences, and going deeper into all these conversations. Just show me your examples, let's talk about that, and so forth. And for now, thank you very much.